If you've heard anything about quantum mechanics, you've probably heard of Schrodinger's cat. It's a famous thought experiment, not a real experiment, in which a cat is said to be both alive and dead at the same time. It's in a quantum superposition. But what does that really mean? What is a quantum superposition? Does this bizarre thought experiment relate to the real world at all? Well, yes and no. The idea behind Schrodinger's cat relates to a very real phenomenon, the fact that in the quantum world, sometimes a particle appears to be doing two contradictory things at the same time. Take the double slit experiment. In that experiment, an electron appears to pass through two slits in the screen at the same time. We can explain this by describing the electron as a wave, but we could also say the electron was in a superposition of all the possible paths. Add up all those paths and you get something that looks like a wave. In a sense, superpositions are just a way of talking about quantum uncertainty. In quantum mechanics, we can't know any property of a particle with 100% certainty. Not because our measurements aren't good enough, but because quantum mechanics simply doesn't allow it. So if we can't say if the particle is over here or over here, then for all practical purposes, it's in both places at the same time. And many others. It has to do with the connection between an experiment and an observation. When an electron is moving through space, acting like a wave with no specific location, we can say it's in a superposition. But when we actually observe it splatting against the wall, we only see that splat in one spot, making the observation appears to have destroyed the superposition. The electron had to choose one spot to interact with the wall in. Every time we observe a particle, we're ruining a perfectly good superposition. When this effect was first discovered, physicists argued about the implications. What does it mean to observe an experiment? Does the observer have to be consciously aware of the observation? Are we, as conscious beings, creating reality as we go? The prevailing interpretation at the time was that any isolated quantum system is always in a superposition up until the moment it interacts with the world outside. You could do an experiment inside a sealed box, and as long as the experiment involves quantum uncertainty, the result is in a superposition until the box is opened and observed, no matter what else is in the box. In discussing the situation with his buddy Einstein, Erwin Schrödinger came up with the example of the experiment with the cat to illustrate the absurdity of this idea. We've edited the details of the experiment here to make it feline-friendly, but you'll get the gist. What if, Schrödinger said, approximately, you put a perfectly happy, healthy, sleepy cat into a box with a radioactive atom that has some probability of decaying between now and the end of the experiment. A single atom won't harm the cat, but if it decays, it triggers a Geiger counter that's attached to an alarm clock, which rudely awakens the cat. Now, before you open the box, you don't know the state of the atom. As far as you're concerned, it's in a superposition of intact and decayed, which means the Geiger counter is both triggered and not, which means the alarm clock has both gone off and not, and the cat is both sleeping and awake. Now, you open the box at your peril. A sleeping cat won't even notice, but an awake cat will not be happy to see you after you pulled that stunt with the alarm. According to the thought experiment, though, opening the box is the only thing that settles the cat into one state or the other. The cat is both happily sleeping and angrily awake. Both Einstein and Schrödinger considered this to be nonsense. Surely the cat itself is an observer for the purpose of forcing the particle into a single state, as is, for that matter, the Geiger counter and the alarm clock. But exactly how quantum states transition from superpositions to something more definite is still an open question, as is why particles can be superpositions, but large objects like people can't.
The fable of the Schrödinger cat, who is asleep and awake in superposition, I think is fantastic because it brings to light the mysterious aspect of quantum theory. Superposition, the cat who is happy and sleeping or angry and awake, it's two things at the same time. In which sense? That's a mystery. By itself, we should not think about reality as individual object with properties. And this is a deep change in the nature of reality itself. That's the beauty of quantum mechanics. It forces us, as a huge cultural evolution, to rethink what is reality from scratch.
Quantum superposition doesn't pose any actual danger to cats or to the human beings who love them. In fact, we can use superposition to our advantage in our technology. In quantum computing, superposition is how a qubit, a quantum bit, can be both 1 and 0 at the same time, and that presents a whole new world of extremely powerful computational techniques. Quantum computers aren't on all our desktops yet. But when yours finally arrives, you might want to be careful opening up that box.